Good afternoon, sir. I'm Arshia Anjum from CSC department. Today, I'm here to present a presentation about software usage, software reuse, and software engineering. Software reuse. Software reuse refers to the practice of leveraging existing software assets such as code, components, or designs to accelerate development of new applications. The foundational principle in software engineering aims to reduce development time and cost while improving software quality. By reusing proven assets, organizations can avoid reinventing the wheel and focus resources on innovation rather than duplication. Throughout this presentation, we'll explore key aspects of software reuse, its benefits, challenges, and the best practices for successful implementation. So, what is software reuse? Let us know what is software reuse. Code reuse. So, code reuse. Reusing the existing source code directly in projects to avoid re, redundant coding effort. So there will be some codes already written in the previous projects. So we are going to use the same code for our current software, for our current project, that is called code reuse. Component reuse. Integrating previous independent software modules that provide specific functionality. Design reuse, applying proven architectural pattern, design frameworks, and documentation templates. So sometimes we may use the designs which were used by the previous projects and some templates of that and documentation. Specialization, specification reuse, leveraging uh, existing requirements and specification documents for similar applications. So we use the same documentation for our present project and the same uh, specification document, I mean to say SRS document for the previous project. Why reuse software? The benefits. There are some benefits for reusing a software. Reduce development time. So the time we take for developing a project, if we reuse the previous project, we may reduce the time for developing, and we'll will take the time for improvising the project. Lower cost. So we don't have to pay extra money for that which we have took from the previous project. Improve quality and reliability. Proven components decrease defect rates by 40 to 60% and enhance software stability. So we may have some errors in that. If we have taken the previous one, we may like they are already tested. We'll get an errorless and error-free code. Standardization. Consistent coding and design practices are promoted across the organization. Levels of software use. There are four levels of software reuse: internal reuse, external reuse, planned reuse, opportunistic reuse. Internal reuse. Reuse within a single project or among teams in the same organization, improving efficiency locally. Matlab, if I have, in our company, we have two to three uh, groups. I belong to group A and some person belong to group B. If I am using the person B software and it we both are in same organization, it becomes internal reuse. We are reusing in our organization and the same thing. External reuse, sharing reusable assets across different organizations or open source communities to uh, broaden impact. I come from an X company and another person comes from a Y company. If the Y person is using my project in my ideology or my SRS document in his project, then it comes as external reuse. Planned reuse, designing software components intentionally for reuse from the start, ensuring modularity and adaptability. While we are designing the document, SRS document, or designing design documents, we initially we plan that we are gonna reuse this part of code or this part of project from others. So then that becomes planned reuse. Opportunistic reuse. ADHOC reuses of existing code or assets discovered during development without prior planning. Well, we have to. In this, we are gonna reuse the software without pre-planning. Matlab, if we have an emergency and we took their code for a reuse. How to implement software reuse? Identify reusable assets. So conduct through code audits to find components and designs suitable for reuse. Establish a reuse repository. Create a centralized, well-organized for reusable software assets accessible to all developers. Develop reuse guidelines. Set coding standards, documentation requirements, and version control policies to support reuse. Training and education. Educate development team on reuse principles, tools, and best practices to foster foster adoption. So, key techniques of software use. Component based development. Building systems by assembling independent reusable components. Service oriented architecture. Reusing services across multiple applications via well-defined interfaces. Product line engineering. Creating a family of related products by leveraging a common software platform. Design pattern. Applying reusable design solutions such as a singleton and factory patterns. Framework. Using reusable code structure with extension capabilities to accelerate the development. Challenges of software use. So we have benefits and also we may have some challenges of using the software use. So let us know what are the challenges. Not invented here syndrome. Reluctance to adopt external or pre-existing code even when beneficial. Asset discovery and understanding. Lack of clear documentation makes finding and using reusable components difficult. So, document whatever it may be, the documentation, it may be design document or SRS document. It should be very clear that if anyone opens the document or if anyone watches the document, they should understand all your project or code in the document. If we make that unclear, we may have flaws in our project. Asset discovery and understanding. Lack of clear documentation make finding and using reusable components difficult. Of course. Compatibility issues. Integrating reusable assets into diverse environment can require extensive adoption. So the code should adapt to your environment. Matlab, your system may have a different environment when compared to their system. So it has to be adopted to your environment as soon as possible. Maintenance burden. Reusable components require ongoing updates and support to stay functional and secure. If we take the code from like past 1 year code also, it should be updated because within months there are a lot of things changing, a lot of technologies are changing. So if we reuse a code or if we reuse a module, we have to update it day to day. We have updation is very required. So maintaining that code must be some burden to us. Successful software reuse examples. So here are some examples. Apache Common Libraries, popular Java libraries providing reusable utility components widely adopted in enterprise projects. React UI library, a leading web UI component library used by over 41% of front-end developers globally. Spring Framework, a comprehensive Java framework providing reusable infrastructure for developing for building robust applications. Linux kernel. Modular design enables reuse across devices, powering approximately 90% of cloud infrastructure worldwide. Boost C++ libraries. A collection of peer reviewed, highly reusable C++ libraries trusted by developers for decades. So best practices for software is document thoroughly. A clear API documentation or SRS document and practical uses example are critical for adoption. We have to make sure that our API document and SRS document should be very clear for adoption. Design for reusability. Consider modularity, flexibility, and extensibility from the initial design stage. So, if we are designing a project, our project should be helpful for others. So, we have to design the project so that another people can reuse it again. Rigorously test asset. Through testing, ensures quality, reduce defects, and build trust in reusable components. Establish a reuse culture. Encourage collaboration, instinctive reuse, and integrate reuse metrics into performance evaluation. Measure reuse benefits. Track reuse rate and cost saving and quality improvements to demonstrate value. So, the future of software reuse. All driven reuse tools, cloud based repositories, standardized component models, domain specific reuse, reuse first development. Thank you.